Have you heard of agents with states? That is something that a lot of people do not think yet. Most of the agents that we deal with today are stateless agents. States are like environments. The agents have to remember what is the environment that they are operate in, and then they have to behave accordingly. Apple has released a new benchmark system, a benchmark that is called TOOLSANDBOX, in which one of the things that they are measuring is states. While this video is going to go over this paper called TOOLSANDBOX, it is very fascinating to see the way Apple is approaching agents, and we have a lot to learn. Let's get started with the paper. A stateful conversational interactive evaluation benchmark for LLM tool use capabilities. Once again, do not approach this paper as just a benchmark, rather see how agents could behave, agents could evolve, and what kind of things that Apple are trying to do with this. So one of the main concerns about the benchmarks currently we have got, while previous works focused on either evaluating over stateless web services RESTful API based on a singleton user prompt. What is a singleton user prompt? A singleton user prompt is user goes and then immediately gives everything. User just says, go to weather API, extract weather for this particular country, and then from that calculate something. So user gives everything in a single prompt. That is singleton user prompt. Or an off policy dialog trajectory. Trajectory is like basically the user path. Like this, somebody says this, the agent responds back. So that is basically a trajectory. This is what has been happening so far. Until now, this is what has been happening. So what Apple is trying to bring is TOOLSANDBOX includes a stateful tool execution, implicit state dependencies between tools, a built-in user simulator supporting on-policy conversational evaluation, and a dynamic evaluation strategy for intermediate and final milestones over an arbitrary trajectory. So if you don't know what is a trajectory, then they're going to have something called milestones to figure out how they are achieving the trajectory or the ultimate goal. We show that open source and proprietary models have a significant performance gap. This is the learning number 2. From this paper, the second learning is we can say as much as we want that open source models have caught up with proprietary models, but there is a significant gap according to this paper in the way these models are being used to build tools and are agents. So main thing that you have to understand is LLMs, when they are being used for agents, one of the things that they have to do is call tools. Now they have to call multiple tools. They have to coordinate within the tools. They have to understand their environment. There are a bunch of things that they have to do. And that is exactly what this paper is trying to evaluate. One of the very popular benchmarks that we have got for function calling or a agent use case is BFCL, which is Berkeley function calling, Berkeley function calling leaderboard. But what Apple is trying to bring in here is that, okay, they're going to check the state dependency. They're going to see the conversational part of it. They're going to see the interactive part of it and human authored ground truth. They're going to evaluate on all these parameters. Now, LLMs as autonomous agents capable of observing the real world environments and deciding upcoming actions is becoming a very important aspect. In fact, a lot of people, including myself, my personal reading, most of the things that I do are primarily around how to make LLM do things rather than how to just get answers from LLMs. And that is exactly why they wanted to create this new benchmark that could help in a very stateful conversational interactive nature. And they're talking about the existing benchmarks. One we already discussed, Berkeley function calling leaderboard, tool eval, API bank. Now they're explaining what is a statefulness in this particular case. Task-oriented dialogue often involves tools that are strongly coupled with a world state. What is a world state? For example, it could be a database. This can be a tool that can alter the world state, like turning on internet connection. So you could be just going and asking, okay, I want to search on the internet. Or you could just simply say, I want to see how many medals India has won in Olympics. That's it. Now the agent has to understand, first of all, the user intent, and also agent has to understand what the state is currently. And then the agent has to understand that for this particular user intent, internet is required for me to browse. So the agent also has to have a context about the current internet not being available. So it has to switch on the internet, Wi-Fi or cellular connection. And that is what the statefulness. More interestingly, there can be a tool that implicitly depends on some world state. For example, one cannot search for a nearby restaurant when the internet connection is off. The agent needs to use its own knowledge about the world and environment feedback to come up with a plan to modify the state and complete task. So for example, let's look at a complete workflow end to end. There are a couple of color coded here. Would like to just inform that whenever you see a blue color, it is a conversation. It is a conversation in which the user is asking something, and the user here is also not a human user. It is an LLM simulated user. I mean, it is trying to be a human, but ultimately it's not a human. They've simulated with an LLM, GPT-4o, I guess. Then you have got the stateful part. So this is an implicit dependency between tools and world states, requiring agent to track and modify world state without explicit user instruction. The user doesn't have to explicitly say, hey, go switch on the Wi-Fi. It doesn't have to happen. They just have to say something, but the agent has to understand and then understand the state and then do certain things. And finally, the interactive part. Conversation trajectory is interactively rolled out during the testing, querying simulated user and real execution environment instead of fixing a predetermined trajectory. So instead of defining A, B, C, it's not like a transition state. I mean, they have DAGs at the end of the paper. You would see them describing things as DAGs, if you're familiar with DAGs. So one of the things that they do is they have these DAGs based on which they calculate milestone scores. But that is not the objective. The objective is that is only for scoring, but that is not what you expect from the agent. So evaluation milestones can dynamically adjust to any trajectory. Now what is happening here? So we have got a message bus, we have got a world state, and we've got milestones, 3 things. This is how much this is achieving. So instead of the final goal, you have got multiple milestones here and there. So milestone is like a certain route in which you want the agent to go. For example, you want to go from Bangalore to the US. So you know that you have to have a stop in Abu Dhabi or Dubai. So Bangalore to Abu Dhabi, Bangalore to Dubai is the first milestone. In fact, like the first milestone could be reaching Bangalore airport. So first milestone, reaching Bangalore airport. Second milestone, Bangalore airport successful check-in. Third milestone, reaching Abu Dhabi airport. Immigration cleared, flying to US. So flying to US is ultimately the final goal, but you have multiple milestones here. And world state is basically you describe the environment like, oh, I've got Uber on, I don't have Uber, I've got flight ticket booked, I don't have flight ticket booked. So this is current your world state, your environment, like what is it you have got. Message bus is where all the conversations happen. And if you have seen my Llama agent video, you would know that Llama agent also has a very similar message bus. So you have got the sender, the user is coming and sending a message, and to the agent, the user is saying, okay, send a message. Now the agent is asking, what would you like to send? So user is saying, send it to Frederick Todendel. Okay. Now the user is just saying the name. User is not saying anything else. Now the agent is figuring out that it has to go to contacts, look for this particular person, and then it interacts. That is where, you can see the statefulness come in. And you can see that now it is interacting. It is interacting, which is extracting the phone number. And then it says, what would you like to say? And the user is saying that, how's the new album? And now it knows at this point that it has to trigger this action called send message. Once again, it is looking at the statefulness, and then it is trying to interact. But while it is trying to interact, there is an error that it has got cellular service not enabled. So without the user human interaction, the agent itself says, okay, we have to switch on the cellular. Now it's just like an action, so nothing gets returned. So it gets returned that, okay, this is done. Now send the message ID has been sent back, relayed back. And then the agent tells the user that your message has been sent. And at this point, it calls end conversation and the agent workflow. The trajectory is completed. And during the same conversation, you would have noticed at the start of this conversation, the cellular was off, message was off. But at some point, the agents decided to switch on the cellular, set cellular service on. And also there is a new message. Previously, let's say there was 0 message. Now there is a new message. In terms of milestone, you can see that search contacts is a milestone, first milestone. And then it is going to the cellular DB looking for the, let's say the contacts. So it says send message called with arguments. There are 2 arguments. One is a phone number and the message. And now there is a message database in which that the entry has been made, like the transaction has been done, and that is a milestone. This is phenomenal. And the way they have designed these tools is that you have got the start, user is asking something, it is going to the agent is responding back. So number of interactions, and then agent is interacting with, let's say, the interactivity part, like the environment, and then getting the response back. And ultimately, if everything is done from the environment, like the interactivity part, we end. One other thing that also they have done is to make sure that they are evaluating things properly. They have done a lot of augmentation. So they have given distraction tools. Like for example, if there's a task for which you just need calculator, they throw like bunch of random tools so that you're trying to intentionally confuse the LLM to see if the LLM would pick up the right tool. And there are a bunch of other things that I'm going to leave it for you to read it. Another interesting aspect is also that for a user, they have given a couple of constraints. One is the knowledge boundary, basically what the user knows, what the user doesn't know. In this case, this is quite helpful because this is a LLM simulated user, not like the real user. Maybe in the real user, it may not be required, but they've given two things. One is the knowledge boundary. The second one is a demonstration. One is explicitly saying what they know. Second is like the giving the demonstration of it. And then most important thing here is the execution environment. So there is an execution environment that is responsible for executing tool calls requested by agent and user roles in the form of Python snippets, mimicking the behavior of interactive consoles like IPython, Jupyter. So basically, you have got a code and you want to execute it. So it's a very similar environment. And if you have seen the third prize winner of AIMO conversation, they also had done the same thing. They use the LLM to get the code, but then they execute it like a Python REPL. So that kind of execution environment you have got here. Exceptions raised while executing the code are captured through stderr and enabling the agent to redefine its tool calls through trial and error. So you make a call, there's an error, then it comes back, then you make another call. So there's a lot of trial and error happening. Some LLMs support parallel tool calling, but sometimes you don't need parallel tool calling. For example, let's say in this particular case, you've got a parallel tool calling. You cannot send a message until the cellular has been switched on. So you cannot have like parallel tool calling. So they are talking about places where that they have disabled that parallel tool calling. They also talk about a bunch of other things, like how they tested, like I said at the start of the video. So they have tested it with single and multiple user turns, single and multiple tool calls, the state dependency, like how much the LLM or the agent in this case is like understanding the state and the execution of tools that it has got. And then canonicalization, which is like you give a simple English prompt, how much it understands the prompt and then forms, let's say, the schema guided dialogue. Like for example, in this particular example, if you say 1 billion, can it convert that 1 billion into something meaningful that the computer can understand? If you say dollar, can it convert into USD for somebody to understand? And this is easier, but there are like difficult things, like for example, latitude, longitude. This Friday, when you say this Friday, the agent has to understand you're referring to this particular date. So they've done a lot of these things. Now, looking at the final benchmark, I want to close the video with this. Looking at the final benchmark, it's quite insane that GPT-4o, the May 13th version, is still the best. So these are like the different benchmarks that we just discussed, like different scenarios: single turn, multi-turn, single turn tool, multi-turn tool, and then you have got the state dependency and then canonicalization. And there is one more thing, which is insufficient information. You intentionally give like less information to the agent. Now, when you have all these things, you can see that GPT-4o is the best. The only case where it did not, none of these proprietary LLMs do good, is when you had information insufficiency, which is Mistral 7 billion instruct. Because when you had information insufficiency, all these proprietary models started thinking that, we are genius, we are going to hallucinate even though we don't have a tool. But this model still started looking for a tool when it did not have enough knowledge. So that is a very interesting aspect. Even like Hermes 2 Pro Mistral had better tool calling rather than just using hallucinated knowledge. And you can see the same thing with a lot of other open models. But you can see the vast amount of difference. The average score here is that GPT-4o has got 73.0 and Hermes 2 Pro Mistral 7 billion has got 31.4. And the Mistral, the out-of-box Mistral that Mistral released, the 7 billion parameter model, is 29.8. I'm also surprised that they didn't make any comparison with, let's say, higher bandwidth models like the 70 billion models, because we all know that the smaller models are not really great for agentic tasks. But again, most of the times when we say agentic tasks, it's simply function calling. I think this should open the eyes of everybody who's working with agents and we should come out of the universe where agents are just not function calling. It is much more beyond that, and that is exactly why I wanted to make this video and then explain what the benchmarks are showing, what people are doing, the way they are trying to measure on all these things. You have got a lot of interesting appendix here. You can go see the different cases, the different prompts, the different failures that they have got, and also the DAGs that I was talking about at the start of this call. So overall, this was a very interesting paper from Apple, and if this becomes like a reality within iPhone, a lot of people would love it. iPhone has got already something called shortcuts for automation, but I don't think a lot of people use it, and I also don't think it has got any agentic capability. Maybe that is what is going to come. But either way, I hope you loved this paper review. Let me know in the comment section what you feel. See you in another video. Happy prompting.